Did you know that over 20,000 Americans alone die from some form of genetic disorders? And even though many of those patients go in for corrective surgeries, none of them have actually survived. This has been linked to a form of overdosing of the amount of drugs that would be needed to be used in a genetic alteration. Now, why is there no other way to transport these drugs and so that we won't have so many more overdoses and as many deaths? Simple. Because we simply won't fund or create a new form of transportation other than just the traditional drug cocktail IV drip way. Now, a way to solve this and to save over 20,000 Americans, hopefully, would be to invent genetic nanobots that would be able to go into the bloodstream. They're small enough to attach to each cell, and then from there they could inject just the right amount of drug cocktail used to adjust each cell that will then adjust the genetic alterations. Now, the way these robots will work is they will be made smaller than a human cell. And while this seems daunting, we've already invented small objects that can be comparable to the size of one, it just needs to be smaller. But as of yet, the only nanobot in creation right now, and it's a prototype, can fit on about the quick of my nail, the little white part. That's as small as we can make it right now. But with funding and with more research into it, we can invent them so they can be smaller and they can have more deliverance so that they can go to each cell and then they can safely transfer the drugs. Now, how will these work, you might ask? The way these will work is they will be small little robots based off of, I know this sounds funny, but a sperm cell. Simply because the sperm cell has a design that makes it able to travel through the body at a rapid rate. The way they will look is they will have a cylindrical body with a flagella, which is a little stringy tail at the end. This will propel them to the body, and with two sensing units on the top and a container on the back that will hold the payload or drugs, they will be able to go onto the cell, and then from there they'll grasp the cell and then inject the payload or drugs. Now, some uses that this would come into is we could use this hopefully on adults. The main theory, though, is that it can't work for just adults. There have been cases where they can make adult lab rats have lower cholesterol through their genetics, but they're still trying to test that for humans. Now, the way this would actually be used would be in embryonic studies. Embryonic studies would be, it would be injected into the embryo, and from there, the nanobots would go into whatever cells it needed, and then from there, it would just attach the cells and make any corrections that would be needed. This will hopefully save the 20,000 Americans per year that die for these things from these genetic disorders, and also it'll bring an estimated $3.8 billion into the medical market.